For some time, I will mute all of you. If you have any question, you can type into the chat. After some time, I will unmute and you can ask the questions. So here the term about cloud data engineering. Especially, there are three popular clouds. One is AWS, Azure, and GCP. We have different services under each cloud platform. Especially, we are going to talk about the data engineering services. Simply the person who handles all these services and who manages the storage and who are responsible for the processing of the data, the two different varieties of data processing. That is major responsibility of a data engineer, storage and processing. If you go back to some 10 years back, there was no special designation called data engineer. Because at that moment, the data volumes are very less. Maybe terabytes of data, or within a year, multi-terabyte of data organizations are getting. But nowadays, problem is a lot of organizations per day they are getting multi-terabytes of data. So within a single day, they are getting 20 terabyte of data, 30 terabyte of data. That much of data volumes they are getting. Storing that much of biggest volumes in on-premise database systems or on-premise storage systems is really very costly and also very tough. So if you talk about the on-premise data storage systems and data processing systems, large clusters you need to maintain. The 200s or thousands of nodes you need to engage into your data center. Initial investment is very high. At the same time, monthly maintenance cost is also very high. So that's why organizations are moving their storage platforms into the clouds. Here, especially for data storage and data processing, different data services are there in different clouds like AWS, Azure, GCP. Nowadays, the modern cloud data platform, which is SNOWFLAKE. All these things will be used. But SNOWFLAKE nowadays it is very popularizing, but is not replacement to all other existing services. Especially this is one of the best replacement and alternative to the data warehousing platforms. But the data engineer needs to interact with a lot of other data services, not only with the data warehouse. So simply these services in case of AWS, we have Azure data engineering services. And same thing in Azure, the thing is called Azure Data Engineering Services. Even companies are inviting you to work as AWS data engineer, Azure data engineer, GCP data engineer. But nowadays, a lot of organizations are giving importance for multi-cloud data engineering. Because the client is using some services from AWS, some services from Azure, some other services from GCP, even for the warehouse purpose, he might be using a SNOWFLAKE. So being a cloud data engineer, you should be able to interact with all the other cloud services. That's why different services we need to understand. This thing is called GCP data engineer here. In case of SNOWFLAKE, this is the cloud modern data warehouse. So with more additional facilities when compared with other on-premise data warehouses and cloud data warehouses. Today, as part of beginning agenda, as Saturday, we try to understand Azure Data Engineering Services. And as the next part of today, we will understand about SNOWFLAKE. And tomorrow completely we dedicate our session for AWS Data Engineering Service and GCP Data Engineering Services. So now I'm going to step into the topic of Azure Data Engineering Services. You know, Azure is a cloud platform of Microsoft. My voice is not audible. All of you getting same problem? Just a minute. Voice some disturbance coming. So now please confirm me. Okay. Okay, sir. Now it's clear. I'm going to talk about Azure Data Engineering Services. Azure is a Microsoft cloud platform which provides all infrastructure and all platforms as a service it is offering. Especially in data related, Azure has many products. Number one, Azure SQL. Second one is Azure Data Lake. This is similar to the AWS S3. And third product is here, Azure Synapse Analytics. And fourth product, to perform the ETL operations in the cloud, we have a special product here, Azure Data Factory. And still, if data volume is very high to process that much of biggest volume of data with a high speed, we have a special weapon here, Azure Databricks. This is a Spark cluster in the cloud. So what exactly the Spark and what is its importance and how Databricks is supporting this, everything we will be discussing step by step. And next product is, there is a great importance of NoSQL databases in nowadays OLTP world. Similar to MongoDB, Cassandra, Neo4j, all these are NoSQL databases. Similar to them, in Azure Cloud also we have a NoSQL database, that is Azure Cosmos DB. And nowadays, a lot of data is streaming data. The two high volumes of streaming data is being produced by the applications. Suppose within a second, millions of records are generating, millions of events will be keep on generating. To capture that much of high-speed streams, we have a special system here, Azure Stream. And to maintain security of your applications, to store like user IDs and passwords, or public keys, private keys, or policy keys and policy certificates, of kind of security information you want to store about your data, about your users, about your applications. And one more product we have that is called Azure Key Vault. And we have a ninth product, Azure Provoke. Is a data governance tool. Is a data governance tool in the cloud. Suppose you have many number of storage services are here, especially as part of this. A lot of data objects are there, a lot of files, a lot of tables. About all these files and all these tables, you want to maintain metadata. And you have given so many permissions to different users or to different other third-party applications. From a single pool, you want to monitor all these things and you want to control. At the time, data governance kind of tools will be used. The data governance tool here is Azure Provoke. Of course, this was launched around 1 year back. So previously, for the same purpose, different kinds of on-premise services will be used. How to stop these annotations? 1 minute, sir. Okay. So this is simply a list of Azure Data Engineering products. Similar to that in AWS, around 10 products will be there, which are supporting these data engineering services. In GCP also we have different products. So popular products, 4 or 5 popular products are there. But why so what is the importance of this multi-cloud data engineer? Simply you are labeled as a cloud data engineer. So around 2 years back, strictly industry is taking only AWS data engineers or Azure data engineers or GCP data engineers like this. But nowadays, most of clients are asking for cloud data engineers. That means In case of Azure, if you have this many number of services, your client may not like all the services from the Azure. For example, when you talk about the streaming, Azure streaming is costly. That's why your client may give priority for AWS Kinesis for stream processing of the data. Actually, your client wants to use Synapse as a warehouse, but he doesn't want to use Azure Data Factory as the ETL tool. He wants to use AWS Glue. In this way, your client style is like this. Whatever the services he liked from Azure, he will be taking those things. And whatever the things he liked from AWS, he is taking those things. And similarly, from GCP, some other services he will be taking. Maybe to maintain the time travel kind of features, immediate change data capture features. Only for those purposes, he might be using Snowflake. On that way, if you enter into the data world, that is a mesh of data world, the two complex mixture of the data world, you will be seeing different data services from different clouds. Even for some confidential data, still your client might be using on-premise data storage and processing systems also. Nowadays, your data platform is completely a mix of multi-clouds with on-premise systems. That's why, especially by the 2024 and 2023 ending, what industry required is multi-cloud data instance. But before going to step into this each and everything, first you need to understand what each component is doing, what is the functionality of each and every component. Then only you can do better architecting of your applications, your data applications. Okay, now let's try to understand each and every product here. I'm going to talk about first Azure SQL. In case of Microsoft, you have SQL Server. What is this SQL Server? This is the RDBMS database. Use it for OLT. Of course, you can use it for data warehouse also. When you can use it for a data warehouse, if data volume is less than 2 terabyte, or little extra to the 1 single terabyte, then you can use SQL Server. But in the data warehouses, we are keeping historical data. Years of data you will be keeping. Suppose your organization has 30 years history. On average, on each year, your organization is generating 5 terabyte of data. Now 30 into 5, 150 terabyte of data. Definitely, you cannot, to maintain entire historical data, you cannot keep 150 terabyte data into SQL Server kind of databases. Those databases are best fit for OLTP only. That's why when time comes to use data warehousing systems, even in on-premise systems also, the organizations are using special databases like Teradata, Netezza, Vertica, such kind of databases they are using. Strictly, they are dedicating these databases only for OLTP. But this SQL Server is on-premise. If it is on-premise, what's the problem? You have to set up your own infrastructure. That too nowadays, observe this word, every database is not a single CPU. Generally, in our practicing systems or training systems, we are using single CPU. But in organizations, in the place of production, your database server is not a single CPU. Your data warehouse is a cluster. So cluster means a network of CPUs. A network of CPUs act as a single server. Generally, in SQL Server, you can keep maximum 256 nodes. Node means CPU here, computing machine. So your organization per day is generating suppose 500 GB data. That means within 1 month, 15 terabyte of data it is generated. To support 15 terabyte of data, you cannot keep single CPU machine in the place of production server. we have to go for a cluster. Setting up 256 CPUs, infrastructure cost, just imagine. That means you need to maintain a mini data center. You have to maintain a mini data center. Initial investment is high. That too, here I keep my CPU on a table. But in the data centers, they don't keep the CPUs like a benching tables. They are keeping them into racks. Within rack, 5 or 6 CPUs they will be engaging. Again, multiple racks, rack to rack connectivity. By using network switches, they are connected. Again, if one network switch got failed, again alternative another switch has to be activated. On that way, a lot of networking components you have to use. Not only investment for CPUs, a lot of networking components. A lot of load balancers are required. A lot of firewall ports you need to configure. A lot of security you need to configure. In this way, very risky maintenance if you go for on-premise data systems. Problem number one, initial investment is very high, and also monthly maintenance cost is also very high. That's why simply instead of taking all these risks, the solution, we need to go for cloud databases. Simply we will create a cloud database instance. How much infra is required automatically, the required infra will be engaged into the cloud platform. You need not to worry about the racks, you need not to worry about the routers, you need not to worry about the network switches and all these things. Simply you are creating one instance and you are deploying that instance. Straight away your applications can write into that, can read from that. All required infrastructure will be maintained by the cloud platform. So only you will have to pay to the cloud provider in the style of pay as you go model. So it depends on how much data you are storing, depends on how much data you are processing daily. Based on that, bills will be applied to you. So whatever the problem is with this SQL server in the on-premise database, especially in Microsoft, the solution here is Azure SQL. Now, what exactly this Azure SQL is? Azure SQL is a cloud RDBMS database. Previously, SQL Server is on-premise RDBMS database. This is cloud RDBMS database. That too used for OLTP, online transaction processing systems, where end user transactions are captured and stored and processed. So generally, end user transactions, especially look into your banking application, you are withdrawing money, you are depositing money, you are transferring amount from one account to other account. All these are end user operations, end user transactions. Okay, the OLTP systems are suitable for this one because OLTP systems are working at a record level, not entire batch level. Okay, so used for OLTP, but there is a problem with these systems, with these OLTP systems. That is, they have limited capacity. In what way limited capacity? Just to look into this one. How many max number of nodes you can keep into the cluster for the OLTP? 256 only. Think that daily your organization is data inflow. Your organization's data inflow is 10 terabyte. You cannot keep all the things. Maximum 2 days data, 3 days data you can keep into those things. Got it. That's why here the problem with OLTP systems is limited capacity. Limited capacity in terms of, that means less storage capacity because of 256 limitation. At the same time, less processing speed. These are the major two problems with OLTP systems. That's why what is the solution? Whatever the problem we have, what is the solution for that problem? The solution is keep recent data. Don't keep entire data into OLTP. Suppose my organization has only 5 years history. Per day data volume is 1 GB. Not a problem. I can keep entire 5 years data into this OLTP. But taking a big bank point of view, big insurance company point of view, per day how many transactions are? Millions of transactions. So in that moment, if they have history of, suppose you talk about UHG, which has a 30-year system. On average per day it is generating 1 terabyte. That means within 1 month only 30 terabyte. Got the point. So that is the main problem. That's why like they don't keep entire history into these OLTP systems. They keep only recent data into this one. Maybe the recent data, how much duration is recent, it depends on their data inflow. Per minute, how many transactions are happening, depends on that. Architects will decide. Suppose my data inflow is very high, I keep only 2 years data into that. Your data is very low, the inflow rate is very low, you can keep 4 years data into that. Depends on transactional frequency, architects will be deciding that one. But what about your organization has 30 years history? What about remaining 20 years data? They cannot keep into this one. Even just a school, think in a school kid point of view. He don't carry all the books to the school. Suppose he is doing some 8th standard education or 9th standard education. He brings only 9th standard books only to the school, but not entire history of education books. Because unnecessary workload. If all the data is unnecessarily kept into that occupies that storage, automatically server performance will be down. For example, my laptop has 1 terabyte of storage capacity. If I really store 1 terabyte of data into this one, my system will not on. Because unnecessary burden for my server. So that automatically performance will be low. End users are getting a very, very slow response. If you try to withdraw money from the ATM machine, you have to wait for 1 hour, 2 hours like that. That's why they are compromising. Forcefully they are compromising. Whether they like it or not, it doesn't matter. Forcefully they are compromising. They are keeping only recent. But where entire historical data they have to keep into a special systems called data warehouse systems. Data warehouse systems. I try to explain the same thing with a small peek. Try to understand this. Just imagine all the left side systems are OLTP systems. That too, if you talk about one biggest enterprise organization, they are using multiple OLTP systems. Multiple OLTP systems, not single system. That too, nowadays, these OLTP systems are on RDBMS or on NoSQL systems. For some applications, they are using NoSQLs. For some applications, they are using RDBMS. Today, end of the day, you will get clarity when to use RDBMS, when to use NoSQL. So being a data engineer, you should have clear-cut clarity about all varieties of data storage and data processing systems. So that too, why organization, here I have a question for you. Why organization is maintaining multiple OLTP systems? Why not single?
Different applications maintain different systems.
Different applications are compatible with the different databases. That is reason number one. Think that if all applications are compatible with one single type of database also, they are using multiple database instances. The reason, if your organization has hundreds of applications and lakhs or millions of users, if all applications are writing into one database, reading from one database, means automatically your database server capacity, that means performance will be slowed down, will be down. That's why to distribute that workload, for some applications they are running on top of one database, some other applications they run on other database. Maybe for some applications they are using Oracle database. For some other applications they are using Microsoft SQL Server database. For example, they have an application called Microsoft CRM. Microsoft Dynamic CRM they want to use. If I purchase Microsoft's Dynamic CRM inbuilt, I am getting SQL Server. So that for my CRM application, I am using the database only, SQL Server only. Okay, that's compatible with this. That's why some applications I am running on top of SQL Server database. For some other applications, maybe I am using IBM products, DB2 is the database. For some applications, I am using a NoSQL system. Think that my website background database is MongoDB. Okay, all users details and customers details and product catalogs, everything I am keeping into MongoDB, which is a NoSQL database. In this way, many number of OLTP systems I am using. A critical enterprise system may use hundreds of OLTP systems. Got it. But what's the problem? All these have limited capacity. That's why I'm using recent data. I keep only recent data. Maybe think that as for my example, I'm keeping only 2 years data into this one. But what about remaining entire history? Your organization has 30 years history. What about remaining 28 years and latest data? All the thing, there should be one go down, a biggest go down. That is simply technically called as a data warehouse. Nowadays, data lakes came into the picture, data warehouse came into the picture, even delta lakes also available. Understand? Data warehouse is a old word. Now latest word, data lake, data lake, data lake house, delta tables, and that way many environments are. Step by step, being a data engineer, we need to understand everything. Okay, let's talk about this data warehouse. I'm going to keep some database in the data warehouse place means what should be the eligibility of the database? It should have high storage capacity, point number 1. And second eligibility, it should, even though data volume bigger, it should be able to process the data with high speed. A small example before getting into this one, a small example, I'm talking in Oracle style. I have Oracle database as OLTP. Table 1, case 1. The table is sales. I want a product-wise sales report. Simply I fire a query like this. Select a product ID and sum of amount from sales table. Group by product ID. This query I will fire. Think that if this data volume is 5 GB. In the case number 1, I get this result within 10 minutes. I'm taking case 2. Same table. The data volume reaches 5 terabyte. If I fire a same above query, it may take 10 hours. There is no change in the query. No change in the query. Only change happened in data volume. When data volume is less, good speed. When data volume is high, very bad speed. Even some processors, suppose really as per in 2013, one test conducted by the Yahoo with many databases. The story is like this: 1 terabyte is volume. Operation is sort by 16 columns. Oracle took 3.5 days. 3.5 data. 1 terabyte sort. Understand? But being a ETL developer, every day I used to sort hundreds of tables with the tens of terabytes of data. Only for 1 terabyte, if it is taking like the 3.5 day time, then my processes will be completed. But remember that 10 years back, I'm talking about 2013, 10 years back, this was good speed. 1 terabyte sort in 3.5 days is really very good speed. SQL server has taken 6 days plus time at that moment. MySQL database is hanged out. Got it? So when compared with other databases, other OLTP databases, Oracle marked a good record. But the thing is, after that, they tested with the Teradata. Is one of the popular database. On those days, is very popular database for the data warehouse. Teradata has done the same work in 4.5 hours. Where is 3.5 day? Where is 4.5 hours? But when you fire a query, this should be processed by a machine. This should be processed by a machine, computing machine only, CPU only. Think that here I have 200 nodes. Here I have 200 nodes in the cluster, but Teradata has given the same result in 4.5 hours. What might be the reason? It has a special capacity, special ability called parallel process. All this knowledge is required when you step into the data lakes and data processing levels.
Here you are talking about Teradata is a SQL, like database or
Is a database. Teradata is a database, but used for data warehouse, not for OLTP. If you talk about OLTP complete ACID properties, it should support. It is especially designed for analytics purpose, batch processing purpose, not for end user transactions purpose, because the internal architecture, database architecture is in such a way. Because of this parallel process, what exactly the meaning of parallel process is simple statement, especially for the new guys into the data processing field. Suppose a small task, you have given me a stick. My task is to break that stick. Suppose my capacity, in 1 minute, I can break one stick. If you submit me 10 sticks, how much time that I require? 10 minutes, obviously. Instead of doing that, I have 10 team members. I distributed each stick to one person. Stick 1 to person 1, stick to 2, person 2. Like this 10 sticks, I distributed to 10 people. All people started breaking at a time. What is the time now?
1 minute.
1 minute. So which causes speed here? Parallel processing, because all people started working at a time. Suppose one biggest process done by Oracle in 10 hours. Same data is distributed into 100 machines. 100 machines are parallelly processing the data. Now what is the time? 10 hours divided by 100. 10 hours divided by 100 means that is 0.1 hour. 0.1 hour means that is 6 minutes. Whatever the thing, one non-parallel processing system, even though Oracle is a cluster, there is no parallel process facility. Got it. One table data will be kept in one single CPU. Second table data will be kept in second CPU. But single data cannot be distributed into multiple tables, multiple nodes in the Oracle. But in Teradata, the parallelism facility is there. Because of parallel process, what is the final advantage? High speed. That's why if you are going to keep some database into warehouse place, means not normal databases, you should not keep. My organization is small, I can keep. Because I have less than terabyte of data, I can keep into OLTP, same database, I can keep into warehouse also. Not a problem. But biggest organizations, multi-terabytes, even a lot of organizations have already crossed the petabyte, zettabytes also. 1024 terabyte is 1 petabyte. Even they crossed zettabytes also. Got it. So for that kind of organizations, you cannot keep normal databases here. There should be some special databases like Teradata, Netezza, Vertica, such kind of databases. But all these are RDBMS databases only. But on-premise, remember, these are on-premise databases. Got it. That too, as per industry feedback, that means who already used all these things. As per industry feedback, these databases are good up to 200 terabyte. 200 terabyte. Of course, 200 terabyte might be, it seems as good volume, but for a lot of organizations, it is small volume. All we have good touch with Redbus application. Redbus itself is generating daily 20 terabyte of data per day, not per year. Per day, 20 terabyte of data. That means 200 terabyte volume is within 10 days it will achieve. Just because of 20 days data, you cannot say it as a historical data. History means what? Not days. You should talk about years. That too from beginning to ending. You should be able to talk about all these things. That's why for nowadays data volumes, for biggest organizations, these kind of databases are not worthy. That's why in 2011, with a full-fledged proof, one data storage and processing system came into the market. That is Hadoop. Hadoop is a big data framework, especially here storage is HDFS. Hadoop distributed file system. Hadoop distributed file system. In Hadoop, the storage is HDFS. which stands for Hadoop Distributed File System. Once you understand HDFS basic behavior, then you can understand cloud file system behavior. The cloud file system behavior is exactly similar to HDFS. Okay, Hadoop distributed file systems. So what is the type of file system here? Basically, two types of file systems. I'm not talking about file formats. I'm talking about file systems. Basically, two types of file systems. Number one, normal file system. And number two, distributed file system. In case of normal file system, entire file data will be kept in single CPU. In case of here, distributed file system, the behavior is like this. File is divided into blocks. Blocks are distributed across multiple nodes of the cluster. Example, in HDFS, very beginning Hadoop version block size is 64 MB. Nowadays, in latest version, it starts from 128 MB. This is block size. Suppose your input file is file1.txt. Size is 100 MB. Now this file is divided into two blocks. As block one stored in node 1 of the cluster, and block 2 remaining 36 MB. First 64 MB into block 1, remaining 36 as the block 2. The block 2 will be stored in node number 2. Now the data is distributed across multiple machines. What is the advantage of this distribution? When you submit a job, that means a query, if you fire a query or if you run a job, okay, the job is divided into two tasks. As task 1, the task 1 is for block 1. The task 1 is submitted to node 1. And task 2, this is for processing of block 2 data. This will be submitted to node number 2. Now these two nodes parallelly processing task 1 and task 2. So because of this distribution of the data, parallel process is possible. Advantage of parallel process, previously suppose 1 minute, now the same work is done by two machines parallelly. So within 30 seconds, you can achieve the result. So advantage of parallel process here. You can achieve high speed. Already I told you example. Previously some work by the non-parallel system 10 hours. Same data is distributed into 100 machines. If 100 machines parallelly processing the data, the time will be 10 hours divided by 100. That means 6 minutes. Within 6 minutes, you can achieve that. That too, if you talk about this HDFS, there are some advantages. The first advantage, unlimited data storage. How it is possible? In case of Oracle or SQL Server, if you take any database, there is a limit for number of nodes in the cluster. But in Hadoop, no limit for number of nodes. number of nodes in cluster. That's why this is very high, unlimited storage it is supporting. Second advantage, supports parallel process. Already the explanation is on how parallel process is possible because data is distributed into multiple nodes. Data is distributed into multiple nodes. Multi-nodes are parallelly processing the data. That's why it supports parallel process. Because of parallel process, you are achieving high speed. And third advantage, all varieties of data. Generally, if you are working with the data platforms, you will see different varieties of data like structured data, semi-structured data, and unstructured data. So here HDFS is able to store and able to process all varieties of this data. The structured data examples are DBMS tables, CSV files, or any delimited files. Semi-structured means XML, JSON, such kind of files. Unstructured means your raw text. Suppose whatever the thing content I am typing on the notepad, that is a raw text. Or images, audios, videos, all these are examples of the unstructured data. So here we are able to store any variety of the data and we are able to process any kind of data. That is what the basic advantage is. And fourth one, supports all big data formats, big data compression formats. Suppose if it is normal Windows system, you are compressing your files by using zip files. But the zip files cannot compress multi-terabytes of data. So especially for the distributed computing systems, distributed file storage systems, to compress the data, we have different other varieties of formats like RC format, ORC format, Yavro format, and more popular is Parquet format. Such kind of formats. More in the real time, most of data you are getting in the Parquet formats. So whatever the shape of the data, whatever the format of the file may be, you could able to store and you could able to fast process with high speed. That means faster data processing. All these advantages are with HDFS. Really, we like all these advantages. That's why instead of keeping Teradata, Netezza, Vertica, such kind of systems into the warehouse place, you can keep HDFS. That means Hadoop. In case of HDFS, the Hadoop, there is a warehouse environment that is high. That is similar to their database. All files you are keeping into HDFS. If any structured data that you are keeping into high. But there is a problem. Again, there is a problem with this Hadoop. What is that problem in? If you understand this problem, then you can understand cloud storage, cloud file systems. The HDFS problems. We need to set up biggest cluster in the data center. Biggest cluster in data center. Here, biggest cluster means not 100 nodes, thousands of nodes you can keep. Maybe 4,000 nodes or 5,000 nodes you need to set up. Already I told you, infrastructure cost is very high, networking components cost is very high. Monthly maintenance cost is also very high. That too, during runtime, if a component got failed, immediately you need to replace them. 24/7 power supply should be there. Okay, a lot cool temperature to be provided for the data center. Lot much of maintenance activities will be there to maintain a data center. But I like all these advantages. What are the HDFS benefits we are seeing? All these benefits I like them. But problem is this one. I am not ready to take this risk. That's why the solution for this problem, I want same kind of behavior with the cloud storage systems. with all benefits of above. In case of Azure platform, which supports all these features, is your second product, which is Azure Data Lake. Azure Data Lake is supporting all these features. This Azure Data Lake is very similar to HDFS only. Same thing. This is very similar to AWS S3 also. All these things have copied this kind of behavior from those things. Okay, it's similar to HDFS. Then what is the difference between Azure Data Lake and HDFS? This HDFS is on-premise cluster. Data Lake is on cloud. So based on this, what you can say about this Azure Data Lake? Simply the statement about this Azure Data Lake is a cloud distributed file system, similar to HDFS. What are the benefits of it? All four benefits. First, unlimited storage, similar to Hadoop. Second, supporting parallel process. Third, all varieties of data. All varieties of data storage and processing. And fourth, all big data formats. All formats like RC, ORC, Avro, Parquet, all these things it is supported. I don't set up any cluster. I don't maintain any data center. Simply I take a service from the cloud. The to Microsoft Cloud, the service name is Azure Data Lake. Depends on how much data I am storing into that, how much data I am processing on that. Depends on that my billing, my storage billings and processing bills will be applied. My organization is small. I am storing only GB data. Only for the GB data I need to pay. Your organization is bigger. You are storing 5 terabyte data, 10 terabyte of data. Based on that data volume, you have to pay to that. So depends on how much data you have. Depends on that you need to store. Okay. So charges accordingly. This is simply about Azure Data Lake, but there is additional advantage. Additional advantage here when compared with the HDFS. In case of HDFS, starting block size based on the latest versions. Block size of the file. Starting from 128 MB. But 128 MB is good for very, very big files, but the same 128 MB is bad for small files and medium sized files. But our organization is getting a daily lot of small files, medium sized files, and big size files. But HDFS is only good for the big files, but not for the small and medium files. That's why in case of Data Lake, the starting block size you can configure from 64 KB, not even MB. Suppose very small file, I keep 64 KB block size. My second file is some GB data, I keep 2 MB or 4 MB block size. Or terabyte file, I keep 200 MB file or 100 MB block size. So here for small files, small block sizes, for medium files, medium block sizes, for very big files, big block sizes, I can configure. 5 to 5 different block sizes I can configure. So that any kind of file I can process it with better performance. So this is simply a simple small statement about the Azure Data Lake. In coming sessions, you will be seeing practical part of the lab part of all these things. How you to store and how to process all these things you will be learning. Okay, that's why I'm coming back to the picture. Instead of using this Hadoop kind of on-premise distributed file systems, I can straight away replace this with my cloud storage file system, that is Azure Data Lake. What are the benefits I am getting from the Hadoop? All the benefits are here. At the same time, additional benefit is I can customize block sizes, depends on the input file size. Like a small files, small block size, big files, big block sizes. Like that I can configure. So next onwards, I don't want a Teradata kind of on-premise data warehouses. Hadoop kind of on-premise big data clusters. Straight away I can use Azure Data Lake. Suppose if you are in same thing AWS, you can use AWS S3 buckets. Same kind of behavior. Okay, that too without maintaining any infrastructure. Only for data volumes. Based on the data volumes, you are paying to the cloud provider. But still, there is a problem. The problem with the data lake, the problem with the cloud file systems. Maybe data lake or AWS S3, whatever it may be. The problem with the cloud file system is if data is in file system, we cannot set up relationship between file to file. For example, employee.txt is one file and departmental.txt is another file. Same thing, sales.txt is one transaction file and products.txt is one file. All product details are kept into product file. All transactions are kept into sales file. All customers details are kept into customer files. I cannot set up relationship. But instead of keeping data into a file, if you are able to keep the data into RDBMS tables. In RDBMS, we have a referential integrity concept. If data is in table, by using primary key and foreign key, you can set up relationship between the tables. You can set up, that means you can set up dependency between the tables. Understand? That means we need a facility of referential integrity. That is possible by RDBMS system. Now I need a database. We need a RDBMS database in the warehouse place, similar to Teradata, Netezza, Vertica kind of things. That means the data warehouse should support a parallel process also. In case of Azure, you have a special data warehouse environment here called Azure Synapse Analytics. Okay, Azure Synapse Analytics. Simply, the first one Azure Data Lake is a file system. The second one Azure Synapse Analytics is your data warehouse environment. Like traditional RDBMS, this is also RDBMS. You can maintain relationship between the tables. That too in the data warehouse, we are using a different dimensionality tables. We can maintain all the dimensions. So simply, what are the problem statement we have for the cloud file systems? Here the solution is we need RDBMS in data warehouse with parallel process. You are keeping some database in in data warehouse place means that should support parallel process. Okay, parallel process. So for this examples, Azure Synapse. In case of AWS, that is AWS Redshift. These are cloud RDBMS databases used for the data warehouse. Okay, now we are into Azure pool. That's why let's talk about only Azure for today. And tomorrow we will speak about AWS and the GCP. The service name, the third service here, Azure Synapse Analytics. Azure Synapse Analytics. Actually, this Azure Synapse Analytics is a package of 4 services. 4 Azure services. If I take this service from the Azure, I get 4 products. The first product is Azure Data Lake. That in Azure Data Lake, there are versions like Gen 1, Gen 2. It is giving you Gen 2, which is the latest one. And second service, Azure Synapse SQL Pool DB. Third service, Azure Synapse Spark Pool. This is to process big volume of data with high speed with Spark engine. What is that Spark? About the Spark after the break, we will discuss about it. Still, we have other services. To understand about them, you should know what exactly the Spark is. And fourth product here, Azure Synapse Pipeline. This is similar to ADE, Azure Data Factory. Nothing, sir. Independently, the service is Azure Data Factory for the ETL purpose. Whenever it is part of the Synapse, the same thing is called as Azure Synapse Pipeline. Among these 4 products, the second product is our data warehouse environment. What is that Azure Synapse SQL Pool DB means? That is cloud RDBMS database used for data warehouse, which supports parallel process. Even AWS Redshift also supporting parallel process. Especially in the Google side, we have Google BigQuery for the parallel processing. Okay, about Google products, AWS products in tomorrow's session and tomorrow, or in the remaining part of the workshop, we will be discussing. So Azure Data Lake Gen 2, SQL Pool DB, Synapse Spark Pool, and Synapse Pipelines, which is equivalent to ADF. We have these things. But based on this, observe this word. In case of Microsoft, you have 2 cloud RDBMS databases. Number 1, Azure SQL. Second, Azure Synapse. Simply in short name, I am giving, instead of saying SQL Pool DB, simply in short name, I am saying as Azure Synapse DB. I have 2 RDBMS databases here. Why 2? The first one is for OLTP. Second one is for data warehouse. Both are RDBMS one. And also Synapse is supporting similar to Teradata kind of databases. It is also supporting parallel process. Now come back to this picture. Now we have 2 things. Data Lake, Azure Synapse Analytics. All my file systems I keep into Data Lake. That too, here I use Data Lake as the initial dumping area, which is called as a staging area technically. I collect the data from all the sources. I collect data from all the sources. As an initial dump, as a staging area, I store into Data Lake. After that, I need to perform a lot of transformations. The transform results, again, organized data, I need to keep into my Synapse data warehouse. But who will be doing all these activities? There is another product, that is ADF, Azure Data Factory. How we have Azure Data Factory here? In case of AWS, we have AWS Glue, GLUE, AWS Glue. So here I'm talking about Azure Data Factory. The work style, this is simply a small statement about this one, Azure Data Factory. Azure Data Factory is a cloud ETL. Of course, your work style is not ETL, your work style is ELT. The ETL kind of style is best suitable for small volumes of data. Whenever you want to deal with big data, big volumes of data, your work style should be ELT. Then the processing will be happening with very fast. So ELT stands for extract, load, and transform. extract, load, and transfer. ETL, just reverse it. Extract, transform, and then load it. When to use what kind of style? It is good for small volumes. And ELT, this kind of style is good for big volumes of it. Of course, ADF support both kind of activities. But in majority of the cases, you are dealing with big volumes. That's why your work style should be ELT. So what exactly it is doing is, observe here in step 1, connecting with source systems. Extract data. Load into data lake systems, Azure data lake as a staging area. So simply, this is simply called as what are the data you are dumping into data lake, that is called as the raw data. Another step 3, perform transformations. Transformed results load into your data warehouse environment, which is that means in the data warehouse environment, that cloud data warehouse environment you have loaded. Once data is properly organized into the Synapse, other visualization teams like Tableau people, BI people, I mean, or Power BI people, or ClickView or ClickSense, these people are connecting with the Synapse and they will be visualizing the data. And data science team is using the Synapse data and data lake data, and artificial intelligence team is doing this one. Finally, being a data engineer, you should provision the data to different departments, like to the BI team, to the data science team, to the AI team. In what way, in what shape they need data, on that shape, you need to provision the data. That's why some data you are keeping into data lake, some other data you are keeping into Synapse. For now, simply have idea, all my file systems and raw data I dump into data lake. All the relational data and transformed results with the transformations, those things I will load into Synapse, because that is final my warehouse environment. This is what exactly the purpose of this ADF. More details after break we will discuss. Simply based on this explanation, the work style is like this. Connecting with the source system. Source system can be on-premise database or cloud database, or NoSQL database, or it can be a file system, whatever it may be. This is your first work. Connect with source system and extract the data. After that, you are loading into Azure Azure data lake. This is called extract and load. Once it is loaded, you have to perform different transformations like data cleaning, aggregations, sorting, filtering, lot of the transformations you need to perform. This is what our third work, which is number 3, called as transformations. The transformed results will be kept into the Synapse. Later, different other teams like AI team, or data science team, or visualization or BI team, these things will be there. I just label them AI, data science, and BI. Maybe Tableau, Power BI, ClickView, ClickSense, Cognos TM, and BOS, business objects, whatever it may be. So whatever the tool may be, they are connecting with this warehouse or some files. So data science teams, some data shape should be in the matrix shape. The matrix shape won't supported by the RDBMS. That a multi-dimensional matrix, like triple dimension, 4 dimension, 5 dimension, such kind of dimensions RDBMS cannot maintain. Such data you are keeping into data lake or AWS S3. Finally, data science team is taking from them. AI team also taking from them. Business intelligence team directly they are taking from warehouse. This is what generally working style. Up to now, in the left side, sources are there. Nowadays, most of sources are in clouds. That too with NoSQL clouds, RDBMS clouds, lot of streaming sources. So finally, after understanding all the components, you will be understanding what exactly modern data warehouse in a high level. Because a lot of primary sources, intermediate resources, again staging areas, that to multi-staging areas, finally warehouse and environment. This is what a complex structure of your project. Okay, so what are the things till now we have discussed? This is about only the data services in Azure, especially up to now we discussed about 4 products. One Azure Data Lake. Before that we discussed about Azure SQL. After that we discussed about Azure Synapse. And after that, just now we discussed about Azure Data Factory. Simply Azure Data Factory is a cloud ETL. Whenever a common man asks you, I mean layman, ask you, you can say it's a cloud ETL. But you remember our work style is ELT. But this is just our definition on, but Microsoft has given a special definition for it. It's a cloud data orchestration service. What exactly the data orchestration service? What is the meaning of it? Okay, after a few topics you will be understanding. Okay, so tomorrow I will demonstrate a little practical about all these components. Okay, all of you take a break. After break we will be discussing about remaining products, about Azure Databricks. And very important thing here, Azure Cosmos DB, which is a NoSQL database, and Azure Streaming, Azure Keyword. At least 5 and 6 topics we will cover after break, because that is a little vast discussion. And tomorrow, as a beginning part, we will be discussing about Azure Streaming and Azure Keyword. All of you take a break. Now time is 12:17. Let's make it as 12:20. Exactly, we will meet by 12:37. Okay, sir, same link, all of you. By 12:37, I will log in. Same meeting link, sir. By 12:37, I will start it.